Now in this lecture we'll find out the radius of a circle. In the drawing we have a circle. This is tangent AP. This is tangent to this circle at point P. This is tangent AQ. That is tangent to this circle at point Q. This is tangent BC. That is tangent to this circle at this point. So we define the touching point of tangent BC with this circle. This point is point M. Know that tangent BC equals to 14 units in its length, AB equals to 16 units in its length, AC equals to 18 units in its length. Again, our test is to find out the radius of this circle. So first of all, we'll define the center of this circle. This point is point O. In the next step, we'll join points O and Q together by a straight line. Point O is the center of this circle, point Q is the point on the circle itself, therefore OQ is the radius of this circle. We define the radius of this circle as R. The radius OQ is equals to R, the radius OQ is drawn to point Q, that is the point of tendency of tangent AQ with this circle. And whenever your radius is drawn to the point of tendency, then tangent AQ will be perpendicular to the radius QO. If AQ is perpendicular to QO, it means that this angle equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. Point O is the center of the circle, point P is the point of the circle itself, therefore OP is the radius of this circle, is equals to R. The radius of P is equals to R, the radius of P is drawn to point P, that is the point of tendency of tangent AB with this circle. Whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AP is perpendicular to PO, it means that this circle equals to 90 degrees in its size, and this circle also equals to 90 degrees in its size according to rule 1. So here we can implement also rule 2. Repeat quickly on rule 2. According to rule 2, the lengths of two tangents from a common center point to a circle are equal. In the drawing, we have a circle. This is the common center point, point P. For this common center point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB. So we can actually implement rule 2 in our drawing. In our drawing, we define the length of this tangent BP as X. And focus on this common center point B. From this common center point B, we have two tangents to this circle, tangent BP and tangent BM. And according to rule 2, they are equal to each other. That is to say, BP equals to BM, but BP equals to X, therefore BM must be also equal to X units in its length. What is the length of this line segment MC? MC equals to QC, that is 14, minus QM, that is X. 29. The missing line segment MC equals to BC minus BM. So MC equals to BC, that is 14, minus BM, that is X. So if you found out that MC equals to 14 minus X units in its length. This is a short line segment MC is equals to 14 minus X units in its length. Likewise, we focus on this common center point C. From this common center point C, we have two tangents to this circle, tangent CQ and tangent CM. And according to rule 2, they are equal to each other. That is to say, CM equals to CQ, but CM equals to 14 minus X, therefore CQ must be also equal to 14 minus X units in its length. In the next step, we'll focus on this connection point A. From this connection point A, we have two tangents to this circle. Tangent AP and tangent AQ. And according to two, they are equal to each other. That is to say, AP equals to AQ. So, as you know, if we focus on the connection point A, we have two tangents to this circle, tangent AQ and tangent AP. And according to two, they are equal to each other. That is to say, AP equals to AQ. AP equals to AQ. AP equals to 16 plus x. That is to say, AP equals to PB, that is x, plus BA, that is 16. So in total, AP equals to 16 plus x. So we can write here that AP equals to 16 plus x. And it's also equals to AQ. AQ equals to, in total, AQ equals to QC, that is 14 minus x, plus C8, that is 18. So in total, QA equals to 14 minus x plus 18. And again, QA in total equals to 14 minus x plus 18. So can I give that 14 equals to AQ equals to 14 minus x plus 18. 14 plus 18 is 32. So in total, this expression equals to 32 minus x. Those two sides of the equation are equal to each other. So I can write down that 16 plus x equals to 32 minus x. 16 plus x equals to 32 minus x. Here we'll subtract 16 from this equation. So in this side of the equation, we have to with x equals to 32 minus 16 is 16 minus x. So if you know that x equals to 16 minus x, here we'll add x to this equation and find that 16 equals to 2x. Here we divide this equation by 2 and find that x equals to 16 over 2, that is 8. X equals to 8 units in its length. This is the short line segment BP of the tangent BP that equals to x and x equals to 8. Likewise, this is tangent BM that equals to x and x equals to 8. Here we have MC equals to 14 minus x. That is MC equals to 14 minus x. That is to say MC equals to 14 minus x, x is 8. So 14 minus 8 is 6. And finally, QC also equals to 14 minus x. That is 14. QC equals to 14 minus x. That is 14 minus 8. That is 6. In the next step, we will join points A and O together by a straight line. By joining points A and O together by a straight line, we can derive those two right triangles. We have the upper right triangle APO and the lower right triangle AOQ. So what is the area of quadrilateral APQO? What is the area of this quadrilateral APOQ? Actually, this quadrilateral APOQ consists of those two right triangles, and therefore the area of quadrilateral APOQ must be equal to the sum of the areas of the two components that it consists of. This is to say the area of quadrilateral APOQ must be equal to the area of the first component that it consists of, that is to say the area of the upper right triangle APO plus the area of the second component that quadrilateral APQO consists of. That is to say, it is the right triangle AOQ. And again, the area of quadrilateral APOQ must be equal to the sum of the areas of the two components that it consists of. The first component is the upper right triangle APO. The second component is the right triangle APQ. And therefore, the area of quadrilateral APOQ equals to the area of triangle APO plus the area of the second triangle APQ. So, what is the area of the upper triangle APO? The area of the upper triangle APO is equal to the base of the triangle times the height over 2. We'll choose the base SAP. The height to the base must create 90 degrees with the base. PO definitely creates 90 degrees with AP, because this is the right angle. Therefore, the area of this upper right triangle APO equals to the base AP times the height PO over 2. So the area of the upper right triangle APO equals to the base AP times the height PO over 2 plus the area of the lower right triangle OQA. The area of this lower right triangle OQA equals to the base AQ times the height of the base QO over 2. So it is AQ times the height of the base QO over 2. So if you found out that the area of the quadrilateral APOQ equals to AP times PO over 2, AP is 16 plus 8, that is 24. AP equals to AB, that is 16, plus BP, that is 8. 16 plus 8 is 24. Times the height PO, that is R, over 2. So in total, if you found out that the area of this upper right triangle POA is equal to 24R over 2 plus the area of the right lower triangle OQA. The area of this right triangle OQ equals to the base AQ times the height QO over 2. AQ is 18. According to what is given in the question, times QO is R over 2. Actually, AQ in total equals to AC, that is 18, plus CQ, that is 6. 18 plus 6 is 24. So the base AQ is 24 units in its length. AQ equals to 24 times the height QOQ, that is R over 2. So in total, we found out that the area of quadrilateral APOQ equals to 24R over 2 plus 24R over 2. So here we take 2 is a common factor from those two expressions, and we get that 24R plus 24R is 48R over 2. 48R over 2, 48R over 2 is 24R. So in total, we found out that the area of quadrilateral APOQ is equal to 24 R square units in its size. In the next step, we join points P and M together by side 9. Actually, will join points O and B together by side line. Likewise, we'll join points O and C together by side line. When doing these constructions, we can do 4 right angles. 1, 2, 3, 4. Actually, BC is tangent to the radius OM at point M, and therefore, according to rule 1, this angle equals to 90 degrees inside, and this angle also equals to 90 degrees inside. So this is a right angle, this is also a right angle, this is a right angle, and this is the 4th right angle. So in total, in the drawing, we have 4 right angles, so we'll calculate the area of each of them separately, and then we'll add the areas of the 4 right angles with each other. The area of those 4 right angles plus the area of this triangle ABC is equal to the area of quadrilateral APQO. Then we create an equation that says that the area of quadrilateral APQO according to the first method of calculation must be equal to the same quadrilateral APOQ according to the second method of calculation. We only found out that the area of this quadrilateral APQO according to the first method of calculation is equal to 24 r square inches in size. So in the next step, we find out the area of this quadrilateral APOQ in a different way. That is to say, the area of this quadrilateral APOQ is equal to the sum of those 4, the areas of those 4 right angles plus the area of this triangle ABC. So in total, this area of those 4 right angles plus the area of triangle ABC equals to the area of quadrilateral APOQ. So this will be the second method of calculation. It must be equal to the area of the same quadrilateral APOQ according to the first method of calculation. So first of all, we find out the area of this point triangle OPB. The area of triangle OPB equals to 8r over 2. The base is PB 8 times the height r over 2. So in total, the area of this right triangle OPB equals to 8r over 2, that is 4r. So it is now the area of this point triangle OPB is equal to 4r square inches in size. Likewise, they have this small right triangle BM, this is aim. They have this small right triangle OMC, they have this small right triangle OBM is equal to the base BM, this is x and x is 8, times the height OM, that is r, over 2. So in total, the area of this small right triangle OBM equals to 8r over 2, that is 4r square inches in size. Exactly like this small right triangle OPB, its area is also 4r square inches in size. Plus the area of this third right triangle OMC, the area of this small right triangle OMC equals to the base MC, this is x, and 14 minus x, and 14 minus x is 6, times the height r over 2. So in total, the area of this small right triangle OMC equals to 6r over 2. 6r over 2 is 3r. So the area of this small right triangle OMC equals to 3r units, 3r square units in its size. And finally, the area of this small right triangle OQC equals to the base, that is 6, times the height, that is r over 2. So it is 6r over 2, that is 3r. So if you found out that the sum of the rest of those 4 integrals is as follows. 4r plus 4r is 8r, 8r plus 3r plus 3r is 8r plus 6r, 8r plus 6r is 14r square units in size. So the only thing that is left to do is to find out the area of this triangle ABC. And then we add the area of this right triangle ABC to the sum of the rest of those two 4 integrals, that is actually 14r square units in size, and the sum of the rest of those two for the shapes here will be the area of the big quadrilateral OPQ. So what is the area of this triangle ABC? Actually, we have a special formula to find out the area of a triangle, that we know that the side length of the triangle. Here in triangle ABC, side AB equals to 16 units in its length, side AC equals to 18 units in its length, and side BC equals to 14 units in its length. So we have all the side lengths of this triangle ABC, so we can use the new formula in order to find out the area of this triangle ABC. According to the new formula, the area of triangle ABC is equal to the square root of S times S minus A times S minus B times S minus C. Here S is the semi-perimeter of triangle ABC. A, B, and C are the side lengths of triangle ABC. The semi-perimeter of any triangle equals to the perimeter over 2. Therefore, S equals to the perimeter, that is actually 16 plus 14 plus 18. 16 plus 14 plus 18 is the perimeter, and the perimeter over 2 is the semi-perimeter. So the semi-perimeter of triangle ABC equals to 16 plus 14, that is 30. 30 plus 18 is 48 over 2. 48 over 2 is 24. So in total, we found out that the semi-perimeter of this triangle ABC is equal to 24 units in its length. S equals to 24. A, B, and C are the side lengths of triangle ABC. So we choose A is 16. B will be equal to 14. And C will be equal to 18. So the area of triangle ABC according to this new formula, that is true for any triangle, the area of triangle ABC is equal to the square root of S. S is 24. The same perimeter S is 24. Times S minus A. S minus A is 24 minus 16. Times S minus B. S minus B is 24 minus 14. Times S minus C. S minus C is 24 minus 18. So in total, we found out that the area of triangle ABC, that is the only missing area that we have to find. This question is equal to the square root of 24 times 24 minus 16 is 8 times 24 minus 14 is 10 times 24 minus 18 is 6. So in total we found out that the area of triangle ABC equals to the square root of 24 times 8 times 10 times 16. This expression in total is equal to 107.33 square root in size. So in total we found out that the area of triangle ABC is equal to 107.33 square root in size. The area of this triangle ABC equals to 107.33 square root in size. Therefore, in total, the area of quadrilateral APOQ equals to the sum of the areas of those those four quadrilaterals, that is actually 14R, plus the area of this triangle ABC, that is 107.33 square root in size. So according to the second method of calculation, the area of this quadrilateral APOQ is equal to the sum of the areas of those four small right angles, that is actually 14R, because 4R plus 4R is 8R, 8R plus 3R is 11R, and 11R plus 3R is 14R. So in total, the sum of the areas of those four right angles is equal to 14R square root in size. Plus the area of this triangle ABC is equal to 107.33 square root in size. This is according to the second method of calculation. The area of quadrilateral APOQ is equal to 14R plus 107.33 square root in size. But according to the first method of calculation, we have only found out that the area of quadrilateral APOQ is equal to 24R square root in size. The area of quadrilateral APOQ according to the first method of calculation equals to 24R square root in size. So in the next step, we get an equation that says that the area of quadrilateral APOQ according to the first method of calculation must be equal to the area of the second quadrilateral APOQ according to the second method of calculation. So the equation says that the area of the quadrilateral APOQ according to the first method of calculation must be equal to the area of the second quadrilateral APOQ according to the second method of calculation. So the area of quadrilateral APOQ according to the first method of calculation equals to actually 24R, and it must be equal to the area of the second quadrilateral APOQ according to the second method of calculation. The area of quadrilateral APOQ according to the second method of calculation equals to 14R plus 107.33. And again, if you found out that in this end of the equation we have the area of quadrilateral APOQ according to the first method of calculation must be equal to the area of the same quadrilateral APOQ according to the second method of calculation, or 24R equals to 14R plus 107.33. Here we'll subtract 14R from this equation and get that 24R minus 14R is 10R. So 10R equals to 107.33 107.33. Here 14R we get cancelled. So 10R equals to 107.33. So here we divide this equation by 10. We get that the radius of this circle, that is the radius that we are looking for this question, the radius R is equal to 107.33 over 10 is 10.733 units in its length. But again, if you want to know that the area, the radius of this circle, that is the radius that we are looking for this question, is equal to 10.733 units in its length. So in the next step, I'll start the lecture. So this section our task is to find out the radius of this circle. So in the moment we have a circle, this is tangent AQ, we have also tangent AP and tangent BC, they are all tangent to this circle. In addition, we know that AB equals to 16 units in itself, AC equals to 18 units in itself. This is tangent BC is equals to 14 units in itself. Again, our task is to find out the radius of this circle. So first of all, we define the point of tendency of tangent BC with this circle. This point is point M. We define the radius of this circle as O. We join points O and P together by straight line. Point O is the center of the circle, point P is the point of the circle itself, therefore P is the radius of the circle that we define as R. The radius of P is equals to R, the radius of P is drawn to point P, that is the point of tendency of tangent P with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PO. If AP is perpendicular to PO, it means that this angle is 90 degrees and this angle also 90 degrees according to rule 1. Likewise, we join points O and Q together by straight line. OQ is also the radius of this circle, that is equals to R. The radius of Q is equals to R. The radius of Q is drawn to point Q, that is the point of tendency of tangent AQ with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AQ will be perpendicular to the radius QO. If AQ is perpendicular to QO, it means that this angle equals to 90 degrees according to rule 1. So in the next step, we implemented also rule 2 in our drawing. So I'll take quickly rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. In the drawing, we have a circle. This is the common standpoint, point P. From this common standpoint, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to rule 2, this rule 2 they are equal to each other. That is to say, PA equals to PB. So we can definitely implement rule 2 in our drawing. Why? Because in our drawing, if we focus on this common standpoint, first of all, we define the length of tangent BP as x. So if you focus on this at this common standpoint point B, from this common standpoint point B, we have two tangents to this circle, tangent BP and tangent BM. And according to they are equal to each other. That is to say, BP equals to BM, but BP equals to x according to our definition. Therefore, BM must be also equal to x according to rule 2. Likewise, we focus so here we have BM equals to x, BC equals to 14. Therefore, the missing line segment MC equals to BC must be M. And MC equals to BC must be M. So MC equals to BC, that is 14 according to all this conservation, must be M, that is X according to all 2. So in total, if you found out that the missing line segment MC equals to 14, most X units in its name. So if you focus on this convection point C, for this convection point C, we have two tangents to this circle, tangent CM and tangent CQ. According to 2 are equal to each other. That is to say CM equals to CQ, but that's like now found out that CM equals to 14 minus X, therefore CQ must be also equal to 14 minus X units in its name. Likewise, if you focus on this convection point A. From this connection point A, we have two tangents to this circle, tangent AP and tangent AQ, and according to 2 are equal to each other. That is to say AP equals to AQ. And again, if you found out that according to 2, tangent AP equals to tangent AQ in its name. AP equals to 16 plus X, AQ equals to 14 minus X plus 18. And again, AP equals to 16 plus X and AQ equals to 14 minus X plus 18. Here 14 plus 18 is 32, so in total this expression equals to 32 minus X. Those two sides of the equation are equal to each other, that is to say 16 plus X is equals to 32 minus X. So here we subtracted 16 from this equation. So on this side of the equation we have 20x, so on the other side of the equation we have 32 minus 16 is 16, so in total this side of the equation we have 16 minus x. So in total we should find out that x equals to 16 minus x. Here we added 16 to this equation, and finally found out that 16 equals to 2x. We just we added x to this equation, and finally found out that x plus x is 2x, so 2x equals to 16. Here we divided this equation by 2, and finally found out that x equals to x, 16 over 8, it is 8. 16 over 2 is 8. PV equals to x and x equals to 8. Likewise, BM also equals to x and x equals to 8. Likewise, here MC equals to 14 minus x. 14 minus x is 14 minus 8. This is 6. Likewise, CQ also equals to 14 minus x. This is 6. In the next step, we join points A and O together by side line. Repeat again. We join points A and O together by side line. By joining points A and O, created there two right angles. This is the upper right angle OPA, and this is the lower right angle OQA. And this is quadrilateral APOQ. Quadrilateral APOQ consists of those two right angles, and therefore the area of this quadrilateral APOQ must be equal to the sum of the areas of those two components that it consists of. This is to say, the area of this quadrilateral APOQ must be equal to the area of the first component that it consists of, that is actually the area of the upper right triangle APO, plus the area of the second component that it consists of, that is actually the area of the right triangle APQ. The area of this upper right triangle OPA equals to the base AP times the height PO over 2. And again, the area of the upper right triangle OPO equals to APO equals to the base AP times the height P over 2. Likewise, the area of this lower right triangle OQA equals to the base AQ times the height QO over 2. And again, the area of the lower right triangle AQO equals to the base AQ times the height QO over 2. Okay. AP equals to 16 plus 8, that is 24. Times PO. PO is R, so in total AP times PO is 24 times R over 2. So in total the area of this upper right triangle OPA equals to 24 R over 2. And again, the area of the upper right triangle OPA equals to 24 R over 2. Plus the area of this lower right triangle OQA. The area of this lower triangle OQA equals to QO times AQ over 2. AQ is 16 plus 18, 6 plus 18, that is 24, times QO, that is R over 2. So in total, the area of this right triangle AQO equals to 24 R over 2. So in total, we should find out that the area of those two right triangles, in total, they are equal to 24 R over 2 plus 24 R over 2. Here we took 2 as a common factor for those two expressions. So here we have 24R plus 24R is 48R over 2. 48R over 2 is 24R. So in total, we found out that according to the first method of calculation, the area of this big quadrangle APOQ equals to 24R square root in size. The next step, we calculated the area of this, the same quadrangle APOQ in a different way, and then we created an equation that said that the area of this quadrangle APOQ according to the first method of calculation must be equal to the area of the same quadrangle APOQ according to the second method of calculation. And we joined points on B together by side line, and we joined points on C together by side line. By doing those constructions, we get 4 items, 1, 2, 3, 4. Calculated the area of each of them separately. The area of this small triangle OPB equals to the base OP times the base PB times the height P over 2. PB is 8 times the height PO, that is R over 2. So in total, the area of this entire PBO equals to 8R over 2, that is 4R. Likewise, the area of this small rectangle BMO equals to the base, that is actually BM times the height MO over 2. BM is X, that is 8, times the height MO, that is radius R over 2. So in total, the area of this triangle BOM equals to 8R over 2, that is 4R. Likewise, we calculated the area of this small rectangle OMC. The area of this small rectangle OMC equals to the base CM, that is 14 minus X, times the height OM, that is R over 2. But we already found out that 14 minus X equals to 6, so it is 6 times R over 2. 6 times R over 2 is 3R. Likewise, we calculated the area of this small rectangle OQC. The area of this small rectangle OQC equals to the base QC, that is 6 times the height R over 2. So 6R over 2 is 3R. So in total, we found out that the sum of the areas of those 4 triangles altogether are equal to 4R plus 4R, that is 8R. 8R plus 3R is 11R, and 11R plus 3R is 14R. So this is inside. Repeat again. The sum of the areas of those two quadrants in total they are equal to 14R square in size. We just have to find out the area of this triangle ABC. In this way, we find out the total area of quadrangle APOQ. Why? Because of the fact that the area of quadrangle OPOQ consists of those two 5 components. The 4 components of the small right triangles plus the 5th component, that is the area of this triangle ABC. The sum of the areas of all 5 components that quadrangle APOQ consists of must be equal to the area of quadrangle APOQ. So we also found out that the area of the 4th component that this consists of is 14R square in size. So the only missing area that we have to find out is the area of this triangle ABC. Actually, we use a new formula. We use the new formula in order to find out the area of this triangle ABC. We know that AB equals to 16 units in its length, BC equals to 14 units in its length, and CA equals to 18 units in its length. The new formula says that the area of any triangle ABC could be any triangle, is equal to the square root of S times S minus A times S minus B times S minus C. S is the semi-perimeter of triangle ABC. The semi-perimeter of any triangle equals to the perimeter over 2. The perimeter of triangle ABC equals to the sum of the sides of triangle ABC. That is 16 plus 14 plus 18. 16 plus 14 is 30. 30 plus 18 is 48 over 2. 48 over 2 is equal to 24 units. So in total, we found out that the semi-perimeter of this triangle ABC equals to 24 square units. here in this formula, A, B, and C are the side lengths of triangle ABC. We choose A is 16, B is 14, and C is 18. So the side lengths of triangle ABC. The semi-perimeter S is 24. So we just have to put the data of our triangle ABC inside this formula, and then our formula for the area of the triangle, and this way we find out the area of our triangle ABC. We did it, and we found out that the area of triangle ABC equals to S, that is 24, times S minus 8, that is 24 minus 16, times S minus B, that is 24 minus 14, times S minus 3, that is actually 24 minus 18. So the area of triangle ABC equals to 24, and the square root of 24 times 24 minus 16 is 8, times 24 minus 14 is 10, times 24 minus 18, that is 6. So in total, we found out that the area of triangle ABC equals to 24, and the square root of 24 times 8 times 10 times 6. Actually, in total, this expression equals to, actually the area of triangle ABC in total, this expression equals to 107.33 square root inches. Repeat again, the area of this triangle ABC equals to 107.33 square root inches. So 107.33 plus 14R is the area of this quadrilateral APQ. And again, the area of quadrilateral APQ according to the second method of calculation must be equal to the sum of the areas of the four small right triangles, that is actually 14R, plus the area of the big triangle ABC, that is 107.33. But we already found out that according to the first method of calculation, the area of quadrilateral APOQ equals to 24R. 24R square root inside. And again, we already found out that the area of quadrilateral APOQ according to the first method of calculation equals to 24R square root inside. So we get the equation that the area of quadrilateral APOQ according to the first method of calculation must be equal to the area of quadrilateral APOQ according to the second method of calculation. The area of quadrilateral APOQ according to the first method of calculation equals to 24R square root inside. It must be equal to the area of the same quadrilateral APOQ according to the second method of calculation. The area of quadrilateral APOQ according to the second method of calculation equals to 14R plus 107.33. Okay. So to that we found out that 24R equals 14R plus 107.33. Here we subtract this 14R from this equation. So here we have to leave 107.33, and 24R minus 14R is 10R. So in total we found out that 10R equals to 107.33. Here we divide this equation by 10 and found out that R equals to 107.33 over 10 is 10.733 units in itself. And again, total we found out that the radius of the semicircle equals to 10.733 units in itself. The radius of this circle R equals to 10.733 units in itself. Okay, thank you very much.